All right, let's compare the P of t. So P of t gives the population, this is supposed to say people, gives the population of population, no, gives the population, wow, of people in billions of people of the world t years after 1950. So P of 40 equals 5.3 means that in the year, let's see, 40 years after 1950, so in the year 1990, there are 5.3 billion people in the world. I was trying to figure out a like fancier way to write. I guess you could write that the population of the world was 5.3 billion people, but you know, this gets the same point across, right? Now let's talk about the derivative. So P prime of 60. So first of all, 60 is 1950, 60, so 2010. That in the, I just want to write it in the same spot that they wrote theirs. In the year 2010, the population of people, or the population, I guess you could write, of the world is, let's see, the number's positive, so the population of the world is increasing, or I guess was, this is 2010, we can talk about the fact that it's 2020, was increasing at a rate of 0.078 billion people per year. Your dependent variable per your independent variable. So that means that in 2010 the world population, or the population of the world, was increasing at this rate. All right, let's do number 5. R of t gives the rate in pints per second. So this is R. That oil is flowing in the tank after t seconds. T. Oh, I guess I didn't write that up here. Billions of people. That was P. And then T years. Gotta stay consistent, you know? Okay, so R of 10 equals 3 means that after 10 seconds, oil is flowing into a tank at a rate of 3 pints per second. This one's weird because the original function they already give us is a rate. So that's why I use the word rate in my original function, or original function statement, right? After 10 seconds, oil is flowing into the tank, since that's what R represents, the rate at which oil is flowing into a tank. So oil is flowing into a tank at a rate of 3 pints per second. Now the derivative of that, R prime of 6 equals negative 0.2, means that after 6 seconds, the rate at which oil is flowing into the tank is, what do we say, decreasing or increasing? We'd say decreasing at a rate of 0.2. And we'd have to do our dependent variable over our independent variable. So pints per second, say per second. Or, if you're feeling extra fancy, pints per second squared. Either of those would be acceptable. All right, so let's go ahead and check our understanding now. So basically it says, so the function v of t gives the volume in liters of water in a tank after t minutes. So v is volume, in liters, t is minutes. Read each of the following interpretations and then write the appropriate first or second derivative statement equivalent to it. So we're going to use our units, but it says in some cases the units have been purposely left out in order to make it less obvious which derivative it corresponds to. So we got to watch out for that. So after 3 minutes, the volume of water in the tank, so that means V, is decreasing at a rate, so rate means derivative, of 8 liters per, there's T, per minute. So at 3 minutes, that was our T, the volume of the water in the tank, so V was decreasing at a rate, so V prime of T. When 7 minutes have passed, the instantaneous rate of change of water in the tank is 12 liters per minute. So that means, 12 liters per minute. This is V prime of T. And you can tell because it's liters per minute. So it's the dependent variable per the independent variable. Also, it says when 7 minutes have passed, so that's T. So V prime of 7 would equal 12. Yep. Okay. After 2 minutes, the rate at which the volume of water is decreasing is 5. So the rate at which the volume of water is decreasing, so the rate is decreasing, V prime of T is 5. So after 2 minutes, the rate at which the volume of water is decreasing, so this is T, is 2 minutes, V prime of T is 5. But it is decreasing, so we have to make sure we include that fact that it's a negative. So we'd have V prime of 2 would equal negative 5. When T equals 10, the rate at which the volume of water is increasing, okay, is 4. So that's still V prime of T, and it's increasing, so that means my derivative will be positive, and that's my T. So V prime of 10 equals 4. Tricky, tricky. Okay, so we're going to kind of go through some of these additional learning resources. They're not 100% necessary, but it's helpful, right? So basically, the instantaneous rate of change of a function with respect to its independent variable is determined by computing its derivative, right? It is important to read each and every word in a math problem. Mathematicians tend to not to throw in lots of extra words, so usually every word is important. And so we're going to decide which of the two calculations is appropriate to answer the question. So it's either going to be the original function would be the right answer or the derivative would be the correct answer. And then we are going to make sure to write down our units for these, okay? We're going to skip part B for now. We're going to come back to that later. So water is flowing into a tank, so the volume of water in the tank in liters, so that's V, after t seconds, is given by this function. At what rate is the amount of water in the tank increasing after 15 seconds? So at what rate is the amount of water in the tank increasing after 15 seconds? So we would say V prime of 15 equals 0.030. And our units for that would be liters per second. Whereas this original one would just say after 15 seconds, there are 73.9 liters. So this would just be liters for this first one. Lovely. Now let's talk about this one. Oil is being siphoned out of a tank at a rate of S of T equals 5 minus square root of T gallons per hour. So this is S, where T is measured in hours. So that's T. From 0 to 5. So at what rate is oil being siphoned out of the tank after 2.4 hours have elapsed. So this one's saying at what rate is oil being siphoned out of the tank, and this is the rate at which oil is being siphoned out of the tank. This is already the rate that's happening. Oil is being siphoned out of the tank at a rate of just regular S. So that means regular S is going to be our answer. Just because it says rate doesn't mean you always have to jump to your derivative. If your original function is a rate already, then it's great. So we would say S of 2.4 equals 3.451. So then our units would be gallons per hour, because it's just the plain Jane regular original function, so gallons per hour. Our derivative, if we were going to calculate that, would be our dependent variable per our independent variable. So it'd be gallons per hour, or again, if you want to get extra fancy, gallons per hour squared. Okay, so let's look at some acceptable explanations and some areas where you should avoid working or writing certain things. So these would all be, let's consider this and then look at the different ways that you could write your answers. So the differentiable function v of t gives the volume of water measured in gallons in a tank at time t, where t is measured in minutes. Explain the meaning of v prime of 5 equals -6. So this is my derivative. So after 5 minutes, the volume of water in the tank is decreasing because it's negative at a rate of 6 gallons per minute. So it's your dependent variable per your independent variable. That would be a perfectly acceptable explanation. At the instant when 5 minutes have elapsed, the amount of water in the tank is going down, which is another way of saying decreasing, at a rate of 6 gallons per minute. They still have the 3 big pieces, right? The time it happens at, the decreasing or going down or changing at a rate of something, and then the 6 gallons per minute. They have the numbers explained with units as well as what's actually happening. So numbers explained with units and then going down, at a rate, okay? The amount of water in the tank is decreasing 6 gallons per minute at time t equals 5 minutes. Technically, they still have your 5 minutes, your 6 gallons per minute, and then they have decreasing. Now, look at what here it says. The phrase at a rate of is not absolutely necessary, since the units indicate that the statement reflects the rate of change, right? Something changing over time. However, this is a better sentence for that, right? 6 gallons per minute, 5 minutes, decreasing at a rate. So I would highly recommend keeping that rate part in there when explaining a derivative. These would be considered too vague, and you would probably lose points for them. So after 5 minutes, they have the 5 minutes, right? They have the amount of the water is changing. So they say changing at a rate. But they don't tell you whether it's increasing or decreasing. So this 6 could be positive or negative in your original statement. This also here, after 5 minutes, so they have the 5 minutes, the instantaneous rate of change of water is -6 gallons per minute. So they have 6 gallons per minute, but it's awkward. We don't really speak with negative numbers except for temperature when it's extremely cold. So you have to actually imply like what that negative means, that it's decreasing or that it's going down, okay? And then these ones would be wrong. So after 5 minutes, the rate of change of water in the tank is decreasing at 6 gallons per minute. So when you're talking about, they don't say the amount of water in the tank, right? This is a statement about the rate of change of the rate of change, because they tell you the rate of change that you already have, but we don't have a rate of change originally. Our original thing is just measured in gallons. That's not a rate already. And so they tell you that the rate of change is decreasing. That would be implying that there were gallons per something already, and then now that is changing. So then that's talking about gallons per minute per minute. And so that's not talking about your first derivative. That's going a step further, okay? So that's why that one's wrong. And then this says at the time 5 minutes, during the next minute, and we talked about this previously, if you're looking from 5 to 6 minutes, that's not an instantaneous rate of change. That's an average rate of change that goes over a time interval, okay? And then Excuse me. Also, they messed up their 6 gallons per minute. They just put 6 gallons, which that talks about your original function as well.